Understand how these four parts, the trigger, the function runtime, the input bindings, the output bindings, work together. Think of an Azure function as a tiny automation worker. It doesn't wake up on its own. Something has to trigger it. And that's your trigger. It's what starts your function. The runtime is the invisible orchestrator, detecting events, creating execution context, opening streams, handling retries, scaling, and logging. Input binding brings the data into your function. Your code executes business logic, for example, moving the blob from uploads to processed. Finally, output binding writes the processed data out automatically. So the trigger answers the question when to run. It wakes up your function. The input binding answers the question where's the data. It brings data in. Output binding answers the question where to send the result. And in simple terms, it sends the data out. Runtime takes care of how it all runs. It handles the glue, retries, and scaling. And you as a developer, you need to worry about what you do with the data and the processing logic. Focus only on the logic. Now, the triggers can be any of the Azure resources which we have in the Azure environment. It could be a timer trigger, it could be a HTTP trigger, it could be a blob trigger, it could be an event grid trigger, it could be any DB triggers, live triggers like SignalR triggers, or it could be any of the service bus message or event hub triggers. So these could be any of the things that could trigger your function or wake up your function according to what we have in Azure. And the output binding or the destination of the data could be any of these resources along with other resources in Azure. So it could be a blob storage, after your code runs, you could write the data back to Azure blobs or any database like Cosmos or SQL. You could send it to a SignalR endpoint to publish it or broadcast to several listeners. You could also send a message to the service bus queue. You can write to event hubs, or you can send an event back to event grid. So what you see on the left are the triggers that could trigger your Azure function, and what you see on the right are the destination or the sources where the data could end up after executing your function. So understanding this entire concept in a nutshell: number one, triggers wake up your Azure function. Number two, the Azure runtime brings in the data, glues the trigger, orchestrates execution of your function and the output binding back to the output resources. And the Azure runtime also takes care of scaling, context establishment, and other critical stuff. The input binding is what binds the data that is coming along with your trigger into your object or into the function, and then you execute your code, you deal with the data, you process the data, you execute your logic, and then you have the output binding which writes the processed output into the destination that you specify. We will now dive deep into each of the 8 trigger types, the most common and the most popular trigger types which are used in the Azure environment. And we'll start with the timer trigger and see how all of these components work together in case of a timer trigger. What you're seeing on screen is a timer triggered function. It's a very simple function. The name of the function is called run cleanup job, and it's decorated with the function attribute. That's how we declare that particular method is an Azure function, and the runtime recognizes that this is an Azure function to create the context and create the runtime for this. So we decorate the method with the function attribute and the name along with the function attribute. And in the method, you see that there's a timer trigger. So we have used the timer trigger. So this function is triggered by a timer and not by any other. And this is the function execution context or the function context. So this is established by the Azure runtime, this context, whenever the timer triggers. This is the cron expression or the syntax that we need to specify as to how frequently we need to execute this function. Based on the cron expression, we can schedule any function to run on a minute-by-minute basis or a second-by-second basis or an hourly basis or a daily basis or maybe weekly or even monthly basis. So there's a specific syntax we may need to be aware of to schedule the trigger of the function of the timer trigger. And then this is nothing but accessing the context objects and writing the log information and all that stuff. Use monitor is an attribute that we specify to a timer trigger, which is basically signaling the runtime to keep information about the state of the timer trigger. Meaning whenever the timer trigger triggers, the runtime keeps state that, okay, this timer trigger is triggered at this point in time, the function executed with or without errors. And in case we set this to true, which in this case it is, it's a signal to the Azure runtime saying that it needs to maintain the state, and if there are any missed triggers, or if a trigger did not trigger or the function did not execute at the particular point in time, the runtime will check the status of it, and then it will make sure or ensure that even the missed triggers or the missed executions are executed. So this state information that we have enabled over here goes and sits in the Azure storage account of the function app. So that's what this particular attribute says for this timer trigger. And then run on startup is another parameter or property that we can set on this timer trigger, which indicates that whenever we kind of start an Azure function, when we deploy it, or even when we are running it locally, whenever we start this Azure function, the timer triggered Azure function, run on startup, when it's enabled, it ensures that as soon as the function is triggered and it's executing, the logic will run for the first time, irrespective of what schedule we have set in this particular cron expression. So that's what this run on startup does if it's enabled. So now if you want to visualize it in the 5 aspects that we have discussed, which is the trigger, the runtime, the input binding, the output binding, what goes on behind the scenes. So this is how we can visualize it. So what you're seeing on screen is a timer trigger. So timer trigger triggers the Azure function. It's a very simple basic diagram. And we went through this particular timer trigger attribute and the properties that we can set and what is the significance of it. If you want to just visualize it, though, so the timer trigger, this particular timer trigger, as you can see the syntax, it's scheduled to run every 5 minutes. So after every 5 minutes, timer is behind the scenes, will trigger this Azure function. After it triggers, the Azure Functions runtime is what manages the schedule, the invocation of the function. It handles the timer state, also executes the missed runs. It manages scaling as well, and it's time-based execution. Then we have the logic that we have to execute. So this is the custom logic and varies from use case to use case or project to project or person to person. So this is where we write our custom logic as to what we have to do once the timer trigger starts. If needed, we can specify an output binding. So the output binding can be any of the resources that we have discussed earlier. It could be a blob, it could be a Azure table, it could be a SQL database, it could be a Cosmos database, it could be an event grid, service bus, event hub, or it could be any other Azure resource. So that is what the output binding could be in this particular timer triggered Azure function. So the cron expression takes segmented format. So seconds allowed values are 0 to 59, meaning which second of the minute you want this function to run. And this is an example, a 0 at the start of each minute. Then we have the minutes, which is 0 to 59. So which minute of the hour /5 is every 5 minutes. Hours 0 to 23, which hour of the day, 2 is 2 a.m. and then day of the month is between 1 to 31. So if you specify 15th, it's the 15th day of the month. Then month, you can specify values from 1 to 2 or Jan to December. So 3 means March, so that's an example. And then the day of the week, 0 to 6 or sun-sat, between Sunday and Saturday. You can specify the 3-letter abbreviation to signal which day of the week you need this Azure function or timer triggered function to run. So one specifies Monday, and what you see on the right is just a visual way of understanding the cron expression. So the second, minute, hour, day of the month, and day of the week format. So you can use the same format when you want to understand any cron expression, or you want to decide which cron expression you need to configure your timer triggered Azure function to run. So that's timer trigger. And what are the use cases? The use cases of timer trigger: schedule job, as we have mentioned. So there could be a nightly cleanup, then heartbeat logs, periodic API polling, report generation, and then SLA monitoring and all the stuff. So these are the main use cases of a timer triggered Azure function. Let us move on to the next trigger, which is the HTTP trigger. So if you look at the simple code of HTTP function, so this is the function attribute as discussed earlier. So this function is called create order. This is a HTTP triggered function. So the trigger, you can see that it's HTTP trigger. And then we have other attributes like HTTP request data, which is the input that is coming in from the request. And then we have the function context, which we already know that the Azure Runtime creates for every function. So what we are basically doing inside this is basically reading the body of the HTTP request and then saying that, we have read the request, then sending the response back, which is a 200 response, and saying that the order is received. We are sending the body back from the request that we got as the response. That's a very simple HTTP triggered Azure function. Now we want to visualize it in terms of the 5 components, which is the main crux of any triggered Azure function, which is in terms of trigger, input binding, output binding, Azure Runtime, and all that stuff. We'll go back to this diagram. So what you're seeing on screen is again the basic HTTP client triggering an Azure function. Then we have the line of code where we specify that this function is expected to be triggered by an HTTP trigger. And then we have all these parameters and the values inside that. So this function is triggered by an HTTP client through a post request. This is not triggered by any other request. We mentioned that in case you have not noticed, we have specified the method, the REST HTTP method as well. So if we receive a get for this method, a get request, this method won't be triggered. This method will be triggered only with a post request. The HTTP client with a post request is what wakes up this function. And then the Azure Functions runtime, it parses the HTTP request, it creates the context, and whatever metadata we require for the particular context, for the particular trigger available in the function context, whatever HTTP data, request data we want is taken care in the request object. As you can see, HTTP request data. So the Azure runtime binds all the request information into this particular object. Then, as mentioned, the input binding is HTTP request data. Then we have our function code which receives this request data and also can make use of the context and does some custom logic based on a requirement or use case, talk to database, talk to external resources, and you can specify the output binding. In this case, the output binding is nothing but the HTTP response data, as you have seen in the method signature. It's called HTTP response data. So we send the response, the JSON response back to the caller, whoever is calling this function. So that's what we are doing over here. So that's in a nutshell how a HTTP triggered function runs. So the use cases could be public REST APIs, SaaS webhooks, mobile backends, CI/CD triggers, microservice endpoints, form or data processing, lightweight API gateway, chatbots. Let's move on to the third trigger, which is file upload automation. So again, we decorate this function with the function attribute and the name of the function. In this case, it's process invoice. We have a run method. We have input binding, which is triggered whenever a blob or a file lands in this specific container. So invoices is a container over here and name is the variable, which is the name of the blob or name of the file that gets uploaded into this particular container of the blob storage. Then it's read as a stream. So that's the input file. So the type is stream and whatever information of the file or the file content itself is serialized into this stream parameter or object called input file by the Azure Runtime. In this case, you have specified an output binding. Again, the output binding is again a blob, a different blob. It's writing into a different container with the same file name as it received it. So here we specify the connection. It could be a different connection even in the trigger and the output binding. So this connection can be same or it can be a different connection, meaning it could be different storage account from where the input files are uploaded, and it could be a different storage account where we write the processed file, in this case the output. Again, the type is stream and the output is serialized in this output parameter, which is called the output file, and it's the stream content. The logic is pretty simple. We are taking whatever the file content is. Once it's returned to this container, we just copy that to the output file object, and rest is taken care by the Azure Runtime. So you don't have to write any other code to mention that this is what you have to do, or this is what you have to connect to, or this is where you have to stream it to, or whatever. The Azure Runtime, with just this declaration as the output binding, does all the magic behind the scenes. The only thing it needs is the connection string to the input trigger and the connection string of the storage account for the different blob. If you want to visualize it, the input is a blob. That's what triggers the Azure function. So that's the scenario that we're discussing. Whenever a file lands in this Azure blob storage, which is specified by this particular connection and into this container called invoices container. That's when this function is triggered. So the blob trigger wakes up the Azure function. The Azure function runtime opens the stream. It reads contents and metadata of the file that's just uploaded onto the specific container of the specific storage account, and also creates the context. Here you can see the function context, and then the input binding, which is the stream or file, is the input blob. So that's what is being read. The Azure runtime takes care of binding that as well. And then you have your function logic. In this case, it's pretty simple. You just copy the input file to the output file, which is again the file that is expected to be returned to another blob specified by this particular connection string and into this specified container, which is processed container. So invoice processing, image or video processing, malware scanning, ETL pipelines, backup or archive, PDF generation, notifications, AI ML workflow could be some of the use cases of this blob trigger. Let's move on to the next trigger, which is the fourth trigger, called as the event grid trigger. So whenever an event is emitted in the Azure environment, could be through an Azure resource or a third party or a custom trigger, you can have this event trigger respond to those events. So if you look at the code, the event grid trigger, it's a pretty simple setup. So again, we'll start with the function attribute. The name of the function is called process event in this case, and you have this event grid trigger mentioned over here. So this function can be triggered only by event grid trigger. And then we also have specified the output binding. In this case, the output binding is event grid output. So here we mentioned the topic endpoint. So event grid needs to have a topic and key setting mentioned, along with what events you want to process in the output of the event grid output. So these are the three key things that the Azure runtime needs in order for it to send the processed events to the output binding specified over here. And then you obviously have the function execution context, which is created by the Azure Function runtime. In case of processing or the custom logic, we have very simple. We have that object, we add some data onto it, we enrich the data onto it, and we send it or forward the enriched data back to the destination event grid, which is specified by these parameters in the event grid output binding. So that's all we do in case of receiving an event from the event grid trigger. The function runtime takes care of waking up the function. Through the trigger, it binds the input event to this particular object, and the type is event grid event. Then you have your logic receiving this input, doing some processing or enrichment, and then finally sending it back to the output events, which is wired back to the event grid specified by this particular URI, topic key setting, and what data you're writing to the destination event grid. So it's pretty simple function, event grid trigger. So if we want to visualize it again, so this is how we visualize the event grid trigger. So event grid triggers the Azure function. We have the same code over here, which we saw in the VS Code. So event source could be a storage, or it could be an Azure resource, or it could be any custom event. Then we have the event grid trigger, which wakes up this Azure function. The Azure Functions runtime deserializes the event, it creates the context and the end-to-end wiring. Then we have the input binding, which brings in the event payload through this event grid event. Then you have your function processing logic. Whatever logic you want to do, you basically write code for that here. That's your only job. The rest is taken care by the output binding and the Azure Functions runtime behind the scenes. So that's the event grid trigger. It's resource monitoring, storage blob events, custom events, CI/CD notifications, security alerts, IoT event routing, serverless orchestration, SaaS integration. So those are some of the use cases for the event grid trigger. Next, let's proceed to the database trigger. So the function fires whenever there's a change in the database. Then the trigger fires, the runtime gives the changed data or documents in this case, which is because we're talking about Cosmos DB. The code receives that input documents and then does some logic processing and then writes it to the output database specified in the output binding. That's a simple sequence. So as you're seeing in the code over here, so it's called the Cosmos DB change handler. Name of the function is processing Cosmos DB changes. We have decorated the method with the function attribute. So that's how the Azure runtime knows that this is an Azure function and it has to invoke and create a context and take care of the end-to-end execution. And in this case, as we discussed, it's a Cosmos database trigger. That's what we have specified. So we have to specify what is the source Cosmos database that the runtime needs to watch for. So we have specified the database name, the container name, the connection string, and what is the name of the lease here. And then if the lease does not exist, we need to create the lease in case it doesn't exist. And then this is the input data or the input binding. Whenever there is a change in the documents in this particular Cosmos DB collection or container, that is when the trigger calls this function up, and then the function receives whatever changes have been processed in that particular Cosmos database. And that particular data is available in this input documents through the input binding, and then it's deserialized into this particular object, if you want to call it. And the structure is pretty simple. It's ID, customer, amount, and status. Once we receive this input, we can do some logic or processing over here. So we are just setting the status property to validated, and then we are writing it to the output document, which is nothing but the output of this particular function. So the output, again, we need to specify the destination properly. So we specify the connection string, we specify the database name where it has to land to, and we specify the container name where the output has to land to. And the Azure Runtime takes care of sending this particular output to that particular destination. So it's a pretty simple Cosmos database trigger example. If you want to visualize it again, so it's the same thing. So the database is Cosmos database. In this case, it triggers an Azure function. It's the same piece of code that we walked through earlier. So Cosmos DB is the monitor DB over here. Cosmos DB trigger is what wakes up this function. The Azure Functions runtime, it detects the changes in this particular Cosmos DB. It handles serialization and deserialization into the specified input and output. And it also creates the context, which is the function context in this case. Then the input binding, which is a read-only list of type order, is what the input binding is. So whenever there is a change in this Cosmos database, the changes are serialized into this particular object called input documents, and then again into this type, which is called order in this case. So then runtime takes care of the serialization, deserialization, etc. And then what you have to write is your function logic. Again, it's custom based on the use case and requirements and all that stuff. And then you need to specify the output binding. Output binding is again the Cosmos DB output in this case. So it's writing the processed output into a different Cosmos database if need be, and into a different container, different database. So no SDK code, no other code. Real-time analytics, audit logging, cache invalidation are a few use cases of Cosmos DB trigger or any database trigger. So far, if you have found this helpful and if you think I've earned it, hit that like button, subscribe for more Azure and cloud content, and don't forget to tap the bell icon so you don't miss future videos. Let's move on to the sixth trigger, which is a real-time trigger called as SignalR Trigger. So SignalR Trigger is used in scenarios where you need to process or respond to events in real time. So let's dive into the SignalR Trigger code base. So it's a pretty simple code base, as you can see. The function name is called on client message. In this case, it's decorated by the function attribute signaling the Azure Functions runtime that this is an Azure function and it has to create the runtime and take care of end-to-end processing of this particular function. So now whenever there is a message or whenever a client calls the SignalR endpoint, this function needs to wake up. So how does this function wake up? It is through the SignalR Trigger. So what does the SignalR Trigger need to wake up this function? You can specify a lot of criteria for the SignalR Trigger to signal the Azure Functions runtime to evaluate this before waking up this function. Number one is hub name. So what hub should the runtime watch for changes or messages? You can also specify the category of messages that the runtime needs to check. You can also specify the event type of the message before the Azure runtime invokes this particular function. Then you need to specify the input parameters which the runtime can use to serialize or deserialize the incoming data, event data. And before all of this, you need to specify the connection string, which is the main indicator of which SignalR endpoint the Azure Function runtime needs to watch for new incoming messages. And then once you specify all of these criteria for the Azure Functions runtime to evaluate before invoking this function, that helps the Azure Functions runtime. So once it identifies that there's a new message which satisfies all these criteria, then it creates an invocation context. It deserializes the message into these parameters, the C# types that we have specified. So the user and message that is coming in the incoming payload is serialized into these simple strings, user and message. It also creates the invocation context, which gives you the metadata about the SignalR connection, SignalR hub, and all that data. So you can use both the metadata and the incoming event data in your function, do some processing, and then direct the processed output to any of the Azure resources as we have discussed earlier. So in this case, it's again sending the process SignalR message back to another SignalR hub. So we are composing a serialized message, SignalR message to be broadcasted to a different SignalR connection specified over here, and the hub name specified over here. In this case, it's the same hub name. It's called Chat Hub. This is the output binding, which indicates the Azure Functions runtime that this is the destination. So after processing, the Azure Functions runtime will direct all the processed output to this particular destination. So that's what this code basically says. So if you want to visualize it, so it's the same trigger function concept. So the trigger over here is Azure SignalR Trigger. This trigger is the Azure function. The code is what you have seen earlier while we walked through the code. The client call looks like this. You can see in the bottom left of the screen. So connection.invoke, new message, Alice, or anything, and hello world. In this case, keeping it pretty simple. So the Azure Functions runtime watches this hub name. It checks the category. So the category is messages, and it also checks the event type. So in this case, it's category, and then there's the event type, which is message, new message. So that both the criteria matches, and the data that is coming in is user and message. So in this case, it's John or hello everyone, or it could be Alice, hello world, whatever it is. So once this is sent, the Azure Functions runtime through the binding extension, it knows that it needs to watch the chat hub, needs to respond to events in the messages category for the event type new message, and it needs to map the JSON fields in data to the parameters user and message. So whatever is there in the data payload, it needs to map or serialize or deserialize into user and message that is specified over here in the input trigger or input binding. So before your function is invoked, the runtime takes the incoming JSON event payload. The SignalR binding extension uses the parameter names array to map JSON properties into C# function parameters. So it deserializes the event body using system.text.json into simple types, which is string user and string message. And the invocation, it also creates the invocation context. The invocation context gives us the metadata like connection ID, hub name, headers, and other information about the invocation. So that's the plumbing, a hell lot of a plumbing that the Azure Functions runtime does for each trigger type. So there's a message sent by SignalR client. The SignalR trigger identifies that, wakes up the Azure function. The Azure function runs runtime, does all this magic behind the scenes. And then you have just your code which does the processing, and then you need to signal the direction or the destination where this process message has to land to, specified by the SignalR output binding in this case. And again, the Azure Functions runtime will take care of the magic of wiring that output into this destination. So that's basically SignalR Trigger and SignalR Trigger Azure Function. The use cases are again real-time analytics, real-time scenarios, real-time dashboards. Let us move on to the next trigger, the service bus trigger. So service bus trigger is pretty simple again. So look at the piece of code. So the function is called process service bus order, decorated with the function attribute. Then we have the service bus trigger. The queue name is incoming orders. So whenever a message lands in this specific queue of this service bus, this function is triggered. Connection is specified over here, the connection string, and the message content or whatever is coming in the message is deserialized into this particular object, and it is of type order. Again, it's the same class. It's ID, customer, total amount, and status. So we are setting the incoming order status as processed, and then we are writing that particular object after it's being processed into the output. So output orders. Output order is nothing but the object which is being sent back in the same format to this different service bus specified by this connection, and to a different queue called processed orders queue, and this is handled by the service bus output binding. So again, if you go back to the visualization, same piece of code, service bus message, whenever a message lands in this particular queue, which is incoming orders, that is when the service bus function is triggered. The trigger, which is service bus, wakes up the function. The function's runtime reads the message, deserializes it into the order object, and then creates the context. The input binding is the order and the incoming order. So that's what this is after the serialization or deserialization done by the Azure Functions runtime. So this particular object is available. You write your logic over here, custom processing logic, business logic, whatever logic, and then the function code, that is the function code, and then you specify the output binding where the processed order in this case has to land to. So in this case, it's again landing in a different queue of a different service bus specified by this particular connection. So that's how a service bus trigger is handled by the Azure Runtime. And so now what are the use cases of service bus trigger? So order pipelines, payment workflows, microservice orchestration, and etc. So now here's a question for you. Which of these triggers do you see yourself using the most in your projects? Drop a comment below and let me know. I love reading your thoughts. Finally, let's explore the last trigger type that handles events. It's called the Event Hub Trigger. Imagine a scenario where we have lots of devices deployed in an IoT environment, Internet of Things environment, and these devices send device information to Azure Cloud through IoT Hub and then eventually through Event Hub. So this is the scenario. This function is called process device telemetry. So whatever data the device is sending is called telemetry data, and this function is responsible for processing the device telemetry. So it receives the events from the Event Hub. So from the devices, maybe let's say hundreds of devices, each of the devices is sending device telemetry data, and that telemetry data is collected by the Event Hub, and through the Event Hub, all of this event information is coming to your Azure function. So that's what trigger specifies. So this is device telemetry, and the connection string is specified by the placeholder over here. So this can be configured in your configuration file, and device telemetry is the Event Hub name to which this function is listening to, and events is the data that you receive from the Event Hub. It is deserialized into event data array object, so by the Azure Function runtime. So once you have this events data, you use that data, like you loop through the events, you capture whatever data is there in each payload, you update it, do some processing, and you either enrich it or do some custom processing, write the data to Cosmos database or any other database based on your requirements, and then you send the output based on your again use case and comments. In this case, we are sending the enriched data payload to outgoing event, which is another set of events being directed to another Event Hub. So that's where the output binding comes in place. So you specify the output events. The output events is serialized or deserialized back to this event data collection. And then you have a different connection string over here. If you want to, process telemetry is another Event Hub name where these events are routed to of this particular Event Hub. So pretty simple. If you want to visualize it, it's again the same piece of code. So the devices or sensors in the IoT environment trigger send this telemetry data to the Event Hub, and once it lands on the Event Hub, the Event Hub triggers the Azure function. The Azure Functions runtime is woken up. It reads the event. The function is woken up by the Azure Functions runtime. It reads the event. It creates the context. There is an input binding. It's deserialized into an array of event data type. Then your function code executes, and then you specify the output binding, which in this case is another Event Hub. That's pretty much it. So that's how Event Hub triggers work in case of Event Hub triggered Azure function, and how the bindings work. So no other extra code, no plumbing logic, nothing. The Azure Functions runtime takes care of end-to-end orchestration and binding, serialization, deserialization, scaling, etc. And your only job as a developer or architect is to think of what is the business logic inside the function that is receiving the data from all these triggers, and then based on your use case or your requirements, you can write the processed output into any of the Azure resources or third-party components based on your use case. What are the use cases of Event Hub Trigger? It's again very useful in Internet of Things scenario where you ingest data from thousands of devices into Event Hub, and you have a function processing those events. Understanding the telemetry, real-time analytics pipelines is another use case. Fraud detection is another use case where you can use Event Hub triggered Azure functions. So now you know, triggers wake up your function, bindings connect it, and the runtime does the heavy lifting. Once that clicks, Azure functions stop feeling like black boxes and start feeling like powerful event-driven automations. But here's the catch. Even with all this power, most developers still trip over 12 hidden pitfalls in triggers and bindings. Issues that only show up after you hit deploy. In my next video, I'll show you exactly what those pitfalls are and how to fix them before they ever reach production. Click on the video that is shown on the screen, and I'll see you in the next one.